Alright, given quadrilateral ABCD has vertices at A26, B68, C12, and D at 5,4, proof quadrilateral ABCD is a parallelogram. Which plan for proof for this problem will show that ABCD is a parallelogram? So here's some plans laid out. The first thing that I would do is I would actually click on concept C, coordinate proofs using the midpoint formula. And I would just click till I saw a red box, because this is what's going to give me the rules. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, so this means that to prove, in order to prove parallelograms, that means we would first have to know that, what does bisect mean? Diagonals bisect each other. So let's break bisect down. I'm going to select on bisect. It'll cut the figure into two congruent parts. Okay, so I'm thinking to myself, what have we been working with that can show that we would cut the figure into two congruent parts? Well, that would be the midpoint for each diagonal is, and so if we have a parallelogram and we were to cut this in half right here, so say this is our midpoint M, so that means this segment is the same length as this segment. Now we would have to show that not only does this diagonal that I'm drawing is cut in half by our same point, M, I would have to show that this point has the same coordinates. So midpoint for each diagonal is the same point, so meaning it has the same coordinates. So that is how I would use this theorem to break down. Now if you wanted an example, here's a beautiful example, and this is probably already worked out. So definition of a diagonal, so that's what they first started with. So I would write down diagonals. I would write down that they had a diagonal. Let me scan to it. I just selected to show all because I didn't want to work through the question in order to see all of these answers. So they first, I'm just going off of the reasons. So definition of diagonal. The next thing that I see is a midpoint formula for diagonals. The next thing that I see so is the midpoint formula again for the diagonal. The next thing that I see is that it has, if two lines intersect, then their intersection is exactly 1 point. Two lines intersect, then intersection is at 1 point, and then the next one is definition of midpoint. And do they have anything? They have definition of bisect. So I'm just showing you how I would use the example right there. This blank would be that theorem 6 that if the diagonals bisect each other, then it is a parallelogram. So I just broke down this proof, wrote down all of the reasons from the example to use in this question. So Notice that we have the midpoint formula for the diagonals and that we're proving that they bisect each other. So use the midpoint formula to find the midpoint of segment AD and segment BC. I'm going to pause and see if that's the diagonals. Segment AD is a diagonal and segment BC is a diagonal. So far, so good. Show that the midpoint for both segments is the same. Yes. Finally, use the theorem that states if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Yep, that met all of these. So, two lines intersect, then the intersection is 1 point. This is saying that the midpoints for both segments is the same. So that's what it means. So that's how I would use the example to help me answer this question.